Hello, welcome to this session, a recorded session. We start statistics today. So, under statistics, we're going to first look at sampling and data collection, because such statistics deals with collecting information, what we call data. Okay, that information is collected, and then you analyze the information. After you analyze the information, then you can give a conclusion and also a recommendation. Okay, so it starts with data collection. Okay, it's the first step. Okay, so there's what we call sampling. So in data collection, when we talk about sampling, what we're mainly talking about is um, selecting a small group from a larger group. Okay, because for example, if we were taking data collection of the whole world, okay, that is a very big population. Okay, the whole world is a very big population. So what we can do, we can sample. Okay, we can get few people from each country, about 10 people from each country. Okay, and then we use that to represent actually the whole world. Okay, so sampling is about using what you know about a smaller group to tell you about a bigger group. Okay, so we call this, so the smaller group is called a sample and the larger group is called the population. Okay, so the whole group that you want to find out about is called a population. Okay, well, the small group that you are picking is called what? A sample. Okay, it's called a sample. So now it's often difficult to survey the whole population because it's just too big. Okay, and it's really important that your sample fairly represents the whole population. Okay, so the sample must be something that is representing the whole population, so that when you make your conclusions, those conclusions will actually be things that satisfy the whole population. Okay, for instance, if you got a sample and out of your sample you find that 3/4 of people in your sample like cheese, you are free to estimate that 3/4 of the whole population eventually will like cheese. Okay, now when doing your sampling, you must make sure that you are looking at a random sample. Okay, it must be a random sample, which means that every member of the population should have an equal chance of being in it. Okay, you have to pick your sample randomly. This actually avoids bias. Okay, biasness. Okay, so and the sample has to be big enough. Okay, the sample has to be big enough. All right, so let's look at simple random sampling. There are many types of sampling techniques, but we're not going to go into those details. So simple random sampling, choosing a random sample. To select a simple random sample, you need to assign a number to every member. So during statistics, we do not we don't oftenly use names of people. Okay, we assign them special numbers. Okay, and then we create a list, and each number is representing a particular member. Okay, and then match the random numbers to the members of the population. Then you're just going to be picking them. Okay, so you can pick using a computer, you can put them in a bag and pick randomly. Okay, all those methods can be, but the whole point is that the sample that you're picking has to be random. Okay, so your sample has got to be random. Okay, so now you need to spot problems with simple methods. Okay, so a biased sample is one that doesn't properly represent the whole population. Okay, so to spot these biases, you need to think about when, where, how, and how many. Okay, so these are the key words that are actually used. Okay, when, where, how, and how many. Okay, so let's go forward and do this simple example. Samir's school has 8,000 pupils. Samir is interested in whether these pupils would like to move to have more music lessons. So for his sample, he selects 5 members of the school orchestra to ask Explain why the opinions Samia collects from this sample might not represent the whole school. So to start with here, you are having a situation where the whole population is 800 pupils. Now the mistake Sami is making here is selecting only 5 members. This does not represent the whole population. This number is too little, okay? And he selects 5 members of the school orchestra, and instead of him selecting randomly, he's selecting members that already belong to an orchestra, okay? They already belong to an orchestra, and because of this, these people are already in music, okay? So they are not going to represent the whole population. So the sample isn't random, only members of the orchestra are included, so it's likely to be biased because they already love music, and they they're in favor of more music lessons, okay? So that is how biased samples actually look like, okay? So we move further. Okay, so now in sampling and data collection, data you collect yourself is called primary data, and if you use someone else's data, somebody already collected the data, we call that secondary data, okay? So there are different types of data altogether. So depending on the collection of data, you have primary and secondary, but then you have other types of data. For instance, qualitative data, usually this one is descriptive. It uses words and not numbers, okay? And then you have quantitative data, measures quantities using numbers, okay? So that's the difference between the two, okay? And here these are put in a way that they are easily understood, okay? So the two types of quantitative data. So quantitative data, you're looking at quantities, and here you're going to deal with numbers, okay? For example, heights of people, times taken to finish a race, number of goals scored in a football. So all those, you find that they are numbers. Height is in terms of numbers, time, it's a number of goals, okay? So quantitative data is also split into two. You have discrete and continuous data. These are quite profound statements if you do better to understand them. So continuous, discrete or discontinuous, it's discrete if members can only take certain exact numbers, okay? So for what I like to explain under discrete data is that it lacks a range, okay? It lacks actually what we call the range. um, you cannot actually group it in a range because we're saying that members can only take exact values, okay? So you can't give a range maybe of 1 to 5. There's no such thing under discrete data. But then if the members can take any value in a range, it's called continuous data, okay? For instance, heights and weights, you can group people, okay, according to the weight. I simply want people with a weight maybe of 35 kgs to maybe 75 kgs, okay? So when you deal with such type of data, you know that this was it. Well, you see, first of all, these are numbers. You tell it's a quantitative, and there is a range, so you tell that is continuous type of data, okay? So you can always organize your data into classes, and this is very profound as well, okay? So to record data in a table, you often need to group it into classes to make it more manageable, okay? So discrete data classes should have gaps between them, e.g. okay, so these are what we call classes, 0 to 1 goes, 2 to 3 goes, 3 to 4 goes, okay? And most of these are continuous data, okay? So let me not bore you much with this. Let's go ahead and quickly look at this example that we have here. So Jonty wants to find out about the ages in a whole years of people who use his local library. Design a table he could use to collect his data, okay? So people using the library, the best way here, he starts with those 0 to 19 20 to 39, 40 to 59, 60 to 79, and 80 to above. So this is a good way of actually collecting information, and these we call them classes. Okay, so in columns for the data values, tally to count the data, and frequency to show the totals. Okay, so under tally here, if we would finish this, we would say that let's say those 0 to 19, let's say it was only 1. Here let's say there were only 3. Here let's say there were about 6, and here let's say it was 1, and here it was 0. So these are the actual numbers, eh? Okay, these are the actual numbers, and then the frequency now actually just shows the total. Okay, the frequency actually shows, so the frequency shows the data is discrete to leave gaps between classes. Okay, so that is how so this one we call it grouped type of data. So here it says you can use sampling to estimate the size of a population. It's often impractical to measure the exact number. Okay, so you can use what we call sampling. One morning, fisherman catches 50 fish from a lake. He puts small tags on them and returns them to the lake. In the afternoon, he catches 40 fish, and 10 of them are tagged. Estimate the number of fish that are leaving the lake. So here, you notice that he caught 50 at first. Okay, and he puts tags on them. Then he catches 40, and out of the 40, 10 of them are tagged. Okay, estimate the number of fish living in the lake. Okay, so the way we're going to do this is at first he caught 50, and these 50, all of them were what? Tagged. So this is like so these were tagged, the tag. He puts them back, okay, and he catches 40, and out of the 40, 10. So we can just say that 10 out of 40 were tagged. Okay, so now you remember that 50 were the ones, all of the 50 were tagged. So now the total amount of fish, yeah, we say we don't know, eh? So 50 out of the total that were tagged, so we cross multiply 10 by x. This will give us 10x, and this will give us 0, 0, 20. So over 10, let's see, 0. So this is 2000 over 10. So you find that x happens to be, so this is just an estimate, doesn't mean that those are the amount of fish, eh? That's just an estimate. So you assume that the fraction of the tagged fish caught in the afternoon is the same as the fraction of tagged fish in the whole lake. So that was the assumption we made. If 10 out of 40 were tagged, 50 out of the total were the ones which were tagged. So that's just an estimate. So data can be qualitative or quantitative. You need to know the type of data you've got so you can record and display it in a suitable way. James asks some students how many times they went to the cinema in the last year. Say whether this data is qualitative, discrete, or quantitative. So you can try to see if this is qualitative or quantitative and whether it is continuous. So whether you can check, so if it deals with numbers, you know it is quantitative. If you can group it in classes, you know it is continuous. Okay, that is the thing to know here. So here it says how many times, so you are dealing with numbers there, and you can actually group it. Okay, you can group it in some class. Okay, so this is continuous. All right, so we go over to something. Okay, we've looked at this. Let's look at something interesting now. All right, so we have the mean, median, mode, and range, and these you find them in most all statistic questions. So we start with the mode. So the mode is the most common. It's the most common value or number. The median is the middle value, and this you can only know the median if you group your values in a chronological order starting from the least to the highest. Okay, that is how you can tell. Okay, and the mean is the total of items divided by the number of items, as simple as that. Okay, the mean is the total of items divided by the number of items. Then the range is the difference between the highest and the lowest number. Okay, so these are called averages. Okay, all of them are referred to as averages, and they are used to um, represent certain numbers. Okay, they used to represent something that we have to find out soon. Okay, so those are the things that we have to know. So mode, the most, okay, the most common, median, middle, mean is the average, but it's mean because you have to work it out. Okay, so it's just something to take note of, and then we move on. So let's look at this example quickly. So according to this example, we are having find the median, mode, mean, and range of these numbers. So we have these numbers. So to find the median, we need to group the numbers from the least. So the least number here, it's -4. So -4 followed by -3 followed by -2. Do we have -1? No. So we'll go over to 0. +1 is there. Do we have +2? Yes. Then we've got 3. Do we have 4? No. 3 appears actually twice. Then we've got 5. We have 6 appearing twice as well. Then 9. So yeah, from the least to the highest. So how do you tell, how do you find the what, the mid? So we're starting with the median, the middle number. So we cancel this, cancel that, cancel this, cancel that, we cancel this, cancel that, this and that, this and that. So now you find that two numbers, if you cancel them, we have nothing in the middle. So find that two numbers are on the middle. So if two numbers are on the middle, you add the two numbers, 2 plus 3, divide them by 2 because they are only 2, and this you're going to get 5 over 2, and here you're going to have 2.5. So this is the median. Okay, then the mode, you just look at the most common value. Okay, so the mode is also known as the model value. Okay, it is also called the model value. Okay, so finding the median, we used this thing, and it gave us the median. So there is you might be asked to find the position of the median. Let's see how we can do that. So it's given by the formula n plus 1. Okay, divided by 2. So this gives us the position of the median. N represents the numbers. Okay, so you count them. The numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this you are going to say 14 plus 1. Okay, 14 plus 1. Okay, so that was what we were trying to discuss here. So 14 plus 1, that is 15, so over 2. So 14 plus, that is 15 over 2. This will give us 7.5. So this tells us that the position for the median is actually 7.5, right? 7.5, that's 7.5 is 7.5. So this means that it's between 7 and 8. Okay, it's between the 7th and the 80th position. Okay, that is where the median is. Okay, so when the numbers are arranged, you count 1, 2, 3, 4, 5, 6. Have you seen 7th and the 8th? Okay, but just what I was doing there, I will give you the value nicely. So the mode, you look at the most common, so look at the most common value, 1, 2. So 3 appears 3 times here, so this makes 3 to be what? The most common value. So you just write 3. The mean, you add now the totals. Okay, so let's do the mean nicely. So the mean, you add all the numbers here and then divide by how many those numbers are. So total number of items over the number of items. So you add all these, divide them by 40 because there are 14 numbers. So and then you divide, so you find that here you get the 1 divided by 14, you are getting 2.214. To 3 significant figures here, it is 2.214. Then the range is actually, the highest number is 9. Okay, so the highest number is 9 and the lowest number is -9. So you subtract these. Okay, so that would be 9 minus -4. So that would be 9 plus 4, and you get 13. So this is the range. Okay, that's the range. Let's look at an example. So you have this example, a tricky example as they say. The heights to the nearest centimeter of penguins at the zoo are 41, 43, 44, 44, 47, 48, and 50. And these, the way I'm looking at them, they are already arranged in chronological order. Okay, so two penguins are moved to a different zoo. If the mean height of the remaining penguin is 44.5, find the height of the two penguins that were moved. Okay, so the total height of the 8 penguins, okay, we add this. So the total height, you will find that when we add the total height, okay, so we know that mean, if we were finding mean, so mean we always represent it by x with a bar on top. Right, this is mean. So mean is total, okay, total over number of items. Okay, so the total will be the total height. Okay, adding all these. Okay, and when we add these, we get 3. read 6, 8. Just going through over the example. Then the number of penguins, how many penguins? There are 8. We are told 8 of them. So when we find the mean, we get 6 into 368. That will give us 368 divided by 6. Okay. So the question here was saying that if the mean height of the so two penguins are moved to a different zoo, right? So if two penguins are moved to a different zone, so we are saying that now the total number of penguins, now there are 6. Okay, they are moved to a what? To a different zone. Okay, so if there are 6 and then you multiply them by multiply this now by the mean. So the mean here we found 368 divided by 8. The mean here 368 actually divided by 8 is 46. Okay, it's 46. So they say if the mean height of the remaining penguins is 44, so now the remaining penguins, they have a mean of 44. So this is the mean when before the two penguins are moved. Okay, but then the mean now after the two penguins have actually been moved, it's actually 44. Okay, so 44.5. So what we are basically doing is this, to put it in simple terms. So if we put it in simple terms here, what we are basically doing is this. We are saying that, understanding that mean is equal to total, or just write T over number of items, or write N. So we are told that we had 8 penguins, but then if they remove 2 penguins, we remain with what? 6 penguins. Okay, so I thought now these 6 penguins, they have a mean of 44.5. So we are going to replace 44.5 on the mean. Find the height of the 2 penguins that were moved. Okay, so we first need to find the total number of the remaining penguins. So the total number of the remaining penguins, we just write 2. So the number of penguins now, there are 6. So over 6, we cross multiply here. So T is equal to 44.5 by 6, and this will give us 267. So now this is the total number. So after the penguins were moved, this is the total height of the penguins. So question, you find the heights of the 2 penguins that were moved. So now we are going to say the total number of the penguins at first was 368. So we say 368. This was the total of the heights of the 8 penguins minus the total of the heights of the 6 penguins, and this will give us 101 centimeter. Okay, so now to find the height of the 2 penguins. So the 2 penguins have a height altogether of 10.1. Okay, so 10.1, that is the height altogether. So this means that we can assume that since it's an estimate, the 2 penguins that were picked was 50 and 51, because if we add 50 and 51, what do we get? We get 101. Okay, So we can assume that their heights were 50 and 51. Okay, it's quite tricky, but it's worth understanding. Okay, so we move on to frequency tables and finding averages. Okay, so like I said, the mean, mode, median, range, all these are simply averages. Okay, so now we look at the word frequency. The frequency describes how many times a particular value shows up. Okay, how many in each category in the table. So find the averages from the frequency table. So what is a frequency table? So the frequency table has got numbers, and on the middle it has what we call the frequency. Okay, so we have the mode, the range, the median, the mean. So here we use what we call frequency table, which consists of the numbers, the frequency, and here we need to find okay, so you have numbers here and the frequency. So to get the number in the third column, what we do here, we just multiply the number times its frequency, number times the frequency, number times frequency, number times frequency, and that's how you get the numbers here. So now the mode is just the category with the most entries. Okay, so here we can say the mode is the number that has the highest frequency. For example, the highest frequency happens to be 22, so this means your mode here is 1. Okay, so you can also get this from this frequency table. Okay, it's called the frequency table. So the mode, the number that has the highest frequency, okay, that's the mode. Okay, then the range is found from the extremities of the first column. So you get the lowest and the highest number, you subtract them, and that's how you get the mode. Then the median is the category containing the middle value. Okay, we know what the median is. So to find the mean now, what you do, you need to find the numbers in the third column, divide, so you find the numbers here, and then you find the total. Okay, in this column, the total divided by the total in the second column, which consists of the frequency. Let's see how we can do that. This is pretty much easier, and this is what you should expect at least in the exam. So some people were asked how many sisters they have. The table here shows the results. So find the mode, the range, the mean, and the median in the table. Okay, so here what we are going to do is this. The mode is the category that has the highest frequency. I've already stated that. The mode, the category with the highest frequency, you just look at the frequencies here. The highest frequency here happens to be 15. Okay, so if 15 is the highest frequency, so it means your mode is basically just what? 1. Okay, pretty much easy. The range, you subtract now the highest and the lowest numbers. Okay, the highest and the lowest numbers. Okay, so the number of sisters is here. So okay, so some people were asked, so you find that you're going to do this. The number with the highest frequency was okay, so you subtract the highest and the lowest numbers. So the lowest number happens to be 0. Okay, the lowest number happens to be 0. The highest number is 5, but 5 has, there is nothing for 5. Okay, the frequency is 0, so meaning the highest number will be 4. Okay, so you just subtract 4 minus 0. This will give us 4, and this is your range. Okay, we can't pick 5 because it has a frequency of 0. Now to find the mean, you need to finish the table. You need to add the second column in the table. So you just add the second column to the table, and once you add the second column to the table, we call this table frequency times x. Okay, we call this table frequency multiplied by x because the numbers here are called x, and then this is the frequency. So 0 times 7, that's 0. 1 by 15, that's 15. 2 by 12, that's 24. 3 by 8, that's 24. 4 by 4, 16. 5 by 0, 0. So you add the totals here, they give us 79. The totals here, they give us 46. So we usually say that the mean, okay, the mean, which is denoted by x bar, is equal to summation of frequency multiplied by x over the sum of the frequency. So the sum of the frequency multiplied by x is this one, which is 79. The sum of the frequencies happens to be 46. Okay, so that is 46 there. And here you happen to get 1.72 to 2 decimal places. So this is how you find the mean when you are using the frequency table. Okay, then now the median now, very simple as well, is the category of the mid value. Work out its position, then count through the second column. So to find the position, remember that formula I mentioned. We say n plus 1, this, okay, n plus 1 divide by 2, so this will give us the position, So n is what here? The sum of the frequencies here. So we're going to say 46 plus 1 over 2. This will be 47 over 2. This will give us 23. To give us 23 over 2, so 23.5. okay, so this means that it's halfway between. So this means that the position for the median, it is simply halfway. Okay, 23 and a half. Okay, so 23 and a half simply means that it's halfway between the 23rd value and the 24th value. So that's what we have. So that's the position of this median. Okay, so the total values, they are a total of 7 plus 15 values. Okay, those 20 values, the first two categories, 12 in the third category, equals to 34. So the median 24th must be the category of 2 sisters, which means the median is 2. Okay, so now it helps to imagine the data set out in the order list. Okay, so here you look at 0 appears 7 times, so you write 7 zeros. 1 appears 15 times, this is what you are seeing here. 2 appears 12 times. 3 appears 8. 5 isn't even appearing because there's a frequency of 0. So when you cancel out the way I was doing at first, you find that your median is 2, and this is quite easier to find. So here we're saying it's between the 23rd and the 24th value. So you count 24, so 20, it's just right here. Okay, so you just arrange them, the numbers, nicely. 0 appears 7 times, you write 7 zeros, 1, 15, and there you get the value like that. Okay, and that's how you find the median. Alright, so I've talked quite a lot. I should end the video just here. I think we'll continue through our live discussion today. We'll pick it up from here. Just find time to make sure that you watch and try to understand this.